Okay, so I wanted to talk to you about a type of problem that is useful in a couple different ways. First of all, you may just see this in one of various forms on the first 5 problems of the GED, the ones you have no calculator on. So the concept you could see is greatest. Oh, let me get a pen color that you can actually see. Let's see here. Pen. Something not white? How about something not white? Okay, here we go. You might see a GCF problem. Now, GCF is short for the phrase greatest common factor. So now this particular problem that we have over here to the side is written in my little shortcut method. I don't spell out greatest common factor of 2 and 8, but if you saw it on the GED, it'd probably be some kind of word problem where it says find the greatest common factor, or it might even say what is the greatest common factor that could be used to reduce a fraction. I've seen it that way. So you need to understand this language if you see it, the GCF, the greatest common factor. Well, let's start with these super common words. So I think we all know what greatest means. It means the biggest or the largest. So we're going to be looking for the largest number we can find. What kind of number though? We want common factors. So if I say that you have things in common, those are shared traits or shared ideas. So we're going to look for shared things. And then factors, that's the important part here. You have to understand that a factor is a number that divides another number evenly. Let me give you an example. Divides another number. So a factor is a number that divides another number evenly. For example, 3 is a factor of 15. Okay, because I could divide 15 by 3 evenly with no remainder. If you need any more explanation about what is a factor, you go back and view one of the factor videos. But I'm just going to press on here as if you have been reminded of what a factor is. So now, if you're looking for greatest common factor, probably the method that most teachers teach is they latch onto that finding all factors methods. So let's look at this example where it asked me to find the GCF of 2 and 8. If I were doing a problem like this, they're asking me what's the biggest number that can divide both 2 and 8. So let's go ahead and take a look at 2 and let's look at 8. I am going to use the rainbow method because the rainbow method allows me to see all the factors of 2. Again, if you don't remember the rainbow method, go back and take a look at my Finding All Factors video. But 2 is divisible by 1 and 2. Those are the only things you can divide it by. 8, on the other hand, yes, it's divisible by 1 and itself, 8. But it's also divisible by 2. 2 times what is 8? 2 times 4. So it has all these factors. So right here, what I did was I listed out the factors of each number. And again, the way to find all those factors is a rainbow. But now what am I going to do? Okay, so we found all the factors of each of the number. Now, this problem just requires me to have the greatest common factor. So you can see that 2 and 8 have a few factors in common. They have 1 in common. They have 2 in common. It's not hard to see which of those numbers is the greatest. Of course, it's 2. 2 is the GCF. So the way I would write this as a lazy mathematician who hates to spell is the GCF of 2 and 8 is 2. And you might see a problem like this on the GED. Now, this is a good method. It's useful. But let's look at some problems where it gets a little more complicated. Okay, so here we have another problem. It's find the GCF, the greatest common factor, of 15 and 75. What's the biggest number that can divide them both? So again, you could start this same way. Get my screen right going here. You could start the same way by listing out all the factors of 15 and all the factors of 75. But it's going to be super important that you don't miss any factors, or you might miss the one that's the greatest. So what divides 15? Well, of course, 1 and 15. Okay. And I'm going to go through that way. Is 15 divisible by 2? Well, no, it's an odd, but it's divisible by 3. And 3 times what is 15? 3 times 5. You pair off your factors that way. Of course, 15 is not divisible by 4, and so I'm done with 15. Let's try 75. 75 is divisible, of course, by 1 and 75. That's the first factor pair. Now, 75 is odd, so there won't be a 2. But be really careful. You need to check for all other factors. So like, for example, is 75 divisible by 3? Well, a couple different ways you could do this. You could use your divisibility tricks, or you could use long division. I'm going to use long division real quick because I happen to know it's divisible by 3. But 3 goes into 7, as you know, 3 times. Oh, I lied. As you know, 2 times. How about that? And, of course, 2 times 3 is 6, so I have a remainder of 1. Drop my next digit. 3 goes into 15 5 times. So I can see that it divides by 3 perfectly, and when it divides by 3 perfectly, I get 25. There's 2 of my factors. Now, 75 was not divisible by 2, so it won't be divisible by any number on 2's times tables. 2, 4, 6, 8. I won't try any of those. But I will try the next odd number, which is 5. And obviously, this is divisible by 5 because it ends in 5. So again, let's divide it out to figure it out. And I'm too lazy to do long division again, so I'll use sight division. 5 goes into 7 once, remainder 2. 5 goes into 25 5 times. So the other side of this is 15. If you want to learn to do sight division in your head like I do, go ahead and check out the video on that. Okay, now 75 is not divisible by 7. It's not divisible by 11. I could keep trying those prime numbers up until 15 and know that these are all the factors. And so I have all my factors for 15, all my factors for 75. Once again, you can see they have many in common. 1. They have a common factor of 3. They have a common factor of 5. They have a common factor of 15, but I want the greatest common factor, the largest one they have in common. Of course, that would be 15. So the GCF of 15 and 75 is, whoa, 75 is actually 15. Okay, so this is finding the GCF by the rainbow method. This is how most teachers teach it. This is how many students learn. And if this is the way you learned it, there is nothing wrong with this method. It is a perfectly good method. It's been perfectly good for many, many years. Go ahead and use it if you're comfortable with it. However, some students hate it because they say to me, Kate, I hate factor rainbows. I hate them. They're hard. Okay, if that is you and you think this method is just too cumbrous, okay, I've got another method coming up for you, so make sure you check it. I'm going to give you an alternate GCF method, okay? Next video, look out for it. Okay.